topic called electrochemistry. We have three-pronged approach. First approach is somebody wanted me to talk about conductance. First, I complete it in coming 10-15 minutes. Then we review the NCERT book. Then we review the exemplar problems which I have shared just now. Have you noticed that I have shared exemplar problems in the group? Hello?
Yes.
So at the end of these three approaches, your concept will be clear. Okay. Are we clear about it?
Yes, sir.
So we start with this idea. Somebody wanted me to talk about conductance. Sir, the current flowing through any conductor depends on what? How many amperes of current is passing through a circuit? The current flowing through a circuit is directly proportional to the potential difference, that is voltage, and it is inversely proportional to the resistance offered by the system at a constant temperature. This is called as Ohm's law. I amperage is directly proportional to the voltage, inversely proportional to the resistance. So I is indirectly equal to V by R. It means that voltage across passing through any wire, any resistor, is equal to IR. V is equal to IR at a constant temperature is called Ohm's law. Have you heard about it, sir?
Yes.
Hello?
Yes, sir.
So as per Ohm's law, you know, V is equal to IR or I is equal to V by R. Now I want to take a wire of length L centimeters whose cross-sectional area is A centimeter square. Now the resistance, you know, the water is flowing through a pipeline and the pipeline is offering resistance. The resistance is directly proportional to length of the pipeline. You can observe that more time it takes for water to come if longer is the length of the pipeline. And it is inversely proportional to cross-sectional area of the pipe. The bigger is your water outlet, more readily the water will come. Similarly, the resistance is opposing force to the flow of electric current that is directly proportional to length of the wire and inversely proportional to cross-sectional area of the wire. Are we seeing it clearly, sir? Are you seeing
Yes,
it clearly? R is proportional to L by A. So R is equal to a constant of rho into L by A. Rho is called resistivity. What is rho means? If I take a wire of unit length and unit cross-sectional area, R is equal to rho. Because L is equal to 1, A is equal to 1 centimeter square. The rho is called specific resistance or resistivity. Its units are naturally units of R ohms into centimeter by centimeter square. It means ohm per centimeter or ohm per meter. What are the units of R? Please notice, units of R are ohms. What are the units of rho? Units of R into A by A, A by L. R is ohms, A is centimeter square, and L is centimeter. So the unit of rho appears to be
Ohm centimeter.
Centimeter. And reciprocal of rho, 1 by rho, is called conductance or specific conductance. It is called kappa. Okay. Conductance or conductivity or specific conductance is 1 by rho. You know, rho is equal to R into A by L. Rho has units of ohms centimeter. Therefore, your kappa will have units of ohm inverse centimeter inverse. Ohm inverse is called Siemens per centimeter. Notice, sir, this L by A, length of the wire and cross-section area of the wire used in a particular electrolytic cell always remain constant. You can keep on changing the solutions taken in the electrochemical cell. In a typical cell where you measure conductance or conductivity cell, in a given conductivity cell, The length of the conducting wire and its cross-section area always remain a constant. And this L by A itself is called cell constant, denoted by G hash.
G
What
star.
is G hash means? L by A. Okay. Or you can denote it by G hash, I have. G star, I have no problem. So in this relation, instead of writing R is proportional to L by A, R is equal to rho into G star. Can I write like that, sir?
Yes.
Can I write like that, sir?
Yes.
Sir,
Yes.
I said that 1 by rho is called kappa. So R is equal to 1 by K. What is K, sir? Yes, conductance,
Conductivity.
into G star. Obviously, K is equal to G star by R. Yes or no, sir?
Yes.
Hello? RK is equal to G star. So whenever you multiply the resistance with conductivity, you will be getting cell constant, which is a constant for a given cell, irrespective of the solution you take. Are you clear on this idea, sir?
Yes.
Ladies and gentlemen, we are examining the idea of conductance. Therefore, we agreed upon that rho is equal to R into A by L. That is all obtained by rearrangement. And now reciprocal of resistance is called conductance. In chemistry, we are interested in conductance. Physics people are interested in resistance. Always they are crazy. They are interested in resistance. Chemistry people are interested in conductance. Yes. The unit of conductance is ohm inverse. Ohm inverse is called mho, M-O-H. Sometimes it is called Siemens. I already said that K is equal to 1 by rho. All these you can just work out yourself. I don't want to invest my time. I already stated L by A is called cell constant, which is denoted by G star. Okay, sir? Now, sir, our interest is, what is the equivalent conductivity? Equivalent conductivity of a solution at a dilution V is defined as the conductance due to all ions produced by dissolving 1 gram equivalent weight of an electrolyte in V centimeter cube. That can be 1000 ml, that can be 10,000 ml, that can be 20,000 ml, your wish, of the solution placed between two large electrodes which are 1 centimeter apart. Notice that equivalent conductivity is equal to specific conductivity into V. Because specific conductivity is the conductance representing 1 centimeter cube. Whereas the equivalent conductivity is conductance representing V centimeter cube. Therefore, equivalent conductance is equal to kV. Ladies and gentlemen, do you remember K is equal to G star R? Hello, sir. K is equal to G star R. Do you remember that?
Yes.
Please go back. What is G star, sir? G star is L by A. Do you remember that, sir?
L by A.
Yes.
Are you seeing this relation, sir? K is equal to C into L by A.
Yes, sir.
Okay, sir. What is C, sir? Conductance. Sir, K by C is equal to L by A. 1 by C is called R. Remember, always RK is cell constant. RK means what? Rahim Khan is always equal to constant. Is there any Rahim Khan in our class? Hello?
No, sir.
Remember, Rahim Khan is equal to G star. G star means cell constant. You have to remember that for solving problems. Okay, sir? Ladies and gentlemen, we are looking at this idea. What is the equivalent conductance? Conductance due to all ions present in the entire volume of solution that contain one equivalent mass of the solute. Sir, what is equivalent mass of solute? For example, for H2SO4, molecular weight is 98. Molecular weight divided by number of H plus ions given by H2SO4, that is 2. Molecular weight by N factor is called equivalent conductance. So 98 by 2, 49 is its equivalent weight. If I dissolve that 49 grams of H2SO4 in 100 ml, in 200 ml, in 3000 ml, in 48,000 ml, whatever may be the volume of the solution, I don't care. In that solution, I should put 2 electrodes just 1 centimeter apart. Then I will be getting equivalent conductance given by K into V. Sir, the volume of the solution is equal to 1000 divided by its normality. So you can work it out. Can you, sir? Hello?
Yes.
Chapaya. I'm sorry for the disturbance, sir. We got a bit. I'm sorry. We have taken 82. I will stop. Sir, are we very clear about it? What is the equivalent conductance? Conductance due to all ions present in the entire volume that is given that contain one equivalent weight of any damn solute. What is the equivalent weight of a solute? It is the molecular weight by N factor. What is N factor? For an acid, each molecule gives how many H plus? For HCl, N factor is 1. Therefore, its equivalent conductance and molar conductance both are same. What do you mean by molar conductance? I dissolve 1 mole of any damn solute in V centimeter cube of a solution where the distance between the electrodes is unity. That conductance is called molar conductance. The molar conductance is equal to equivalent conductance if the N factor is 1. N factor is 1 for what? For HCl it is 1 because 1 HCl gives 1 H plus. For HNO3 it is 1. For NaOH it is 1. For KOH it is 1. Wherever only N factor is 1, then equivalent conductance is equal to molar conductance. Equivalent conductance is equal to Kv. Kv is equal to K into 1000 by normality. You should be very cautious about the units of K. Units of K should be Siemens per centimeter. If you are taking Siemens per meter unit, you have to change it to Siemens per centimeter. Do you know how to change, sir? K unit can be Siemens per meter. It can be Siemens per centimeter. Sir, what is the difference between these two? If it is Siemens per meter means the length of your conducting wire is 1 meter and its cross-section area is 1 meter square. If it is Siemens per centimeter means the length of your conducting wire is 1 centimeter, its cross-section area is centimeter square. Both are slightly different. How to convert them, sir? Sir, do you know how to convert them? Siemens per meter. You don't want meter. So if you want to put centimeter, how many centimeters is equal to 1 meter, sir? Hello? By 100. Can you see it, sir? Hello?
Yes, sir.
So Siemens per meter is equal to Siemens by 100 centimeters. In other words, Siemens per meter into 100 is equal to Siemens per meter into 100 is equal to Siemens per centimeter. Are you seeing it clearly, sir? Hello?
Yes.
Sir, please write down in this way. Siemens per meter is equal to Siemens by meter, which is equal to Siemens by 1 meter is 100 centimeters. So if you want to convert the Siemens per meter into Siemens per centimeter, take 100 this side. 100 into Siemens per meter is equal to Siemens per centimeter. So whenever they give you value of the K in Siemens per meter, when you are finding the equivalent conductance, please do convert the K from Siemens per meter to Siemens per centimeter. Then apply this formula, 1000 by normality. Then you will get answer. Students are often forgetting that aspect. So what are the units of equivalent conductance? Units of equivalent conductance is Siemens centimeter square per equivalent. We can also take it in Siemens meter square per equivalent. If you are taking Siemens meter square per equivalent, your normality will not be in equivalence per liter. It should be in equivalence per meter cube. Therefore, that is all big complication. When you are using Siemens meter square per equivalence, you can't just take the normality. You should take number of equivalents per meter cube, and 1 meter cube is equal to 1000 liters. All this is big nuisance. So the best thing is convert the Siemens per meter into Siemens per centimeter, solve the problem. How to convert Siemens per meter into Siemens per centimeter? Multiply Siemens per meter with 100. Finally, you are getting answer in Siemens centimeter square per equivalence. You can convert Siemens centimeter square per equivalence into Siemens meter square per equivalence by just multiplying with 10 to the power 4. So, two operations are to be noticed. Are we very clear, sir? Hello? 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 Hello, are you there?
Clear.
Yes.
Sir, I think there is a little bit confusion and I want you to get clarity on that. Just write down once. Siemens per meter is equal to Siemens per 100 centimeters. It implies Siemens per meter into 100 is equal to Siemens centimeter inverse. So whenever they give the K in Siemens per meter, multiply with 100 to get Siemens per centimeter. Then you will get equivalence in Siemens centimeter square per equivalence. Okay, sir? Hello? Okay. Please remember, Siemens meter square per equivalence can be converted into this. How? Every meter is equal to 100 centimeters. So it is equal to Siemens 100 into 100 centimeter square per equivalence. Can you see it, sir?
Yes.
So when you get the answer in Siemens centimeter square per equivalence, just multiply with 10 to the power 4, then that is equal to 1 Siemens meter square per equivalence. Or in other words, that's the way to do. Are we very clear, sir? Hello?
Yes.
Yes, sir. Clear.
This is needed. Otherwise, your data, you can't take as it is. Now I am looking at this idea further. This is the material I have sent. You have to see that. So this is a clarity on that. What are the units of specific conductance? Siemens per meter or Siemens per centimeter. How they are related? Siemens per meter into 100 is equal to Siemens per centimeter. Then what are the units of equivalent conductance? Siemens centimeter square per equivalence. What is the other SI unit? Siemens meter square per equivalence. How can I convert to Siemens centimeter square per equivalence? I should multiply Siemens centimeter square per equivalence with 10 to the power 4 to get 1 Siemens meter square per equivalence. Are we clear? Now, molar conductivity is conductance due to all ions which are present between two electrodes separated by unit length, which contain 1 mole of the solute dissolved in V centimeter cube of solution. V can be anything. So molar conductance is equal to K into 1000 by molarity. Notice molar conductance is equal to equivalent conductance if N is equal to 1. Its units are same as those of previous. Siemens centimeter square per mole or Siemens meter square per mole. Always remember molar conductance is equal to K divided by K into 1000 by molarity or K by molarity in moles per meter cube. You can't use this. This is a nuisance. Always I suggest you to use K Siemens centimeter square per mole is equal to K into 1000 by molarity. Please use that. This is convenient. Use this formula. Molar conductance is K into 1000 by molarity. Take molarity in moles per liter. Take K in Siemens per centimeter. Okay, sir. Can you solve this problem, please? Resistance of an
Yes.
aqueous solution containing 0.624 grams of copper sulfate pentahydrate per 100 centimeter cube of solution, a conductance cell of cell constant 153.7 per meter. Cell constant unit should be Siemens per meter. The dirty rogue has forgotten to write Siemens. Hello? Look at the solution, sir. Yes, I want you to look at the solution once, and if you get a doubt, you should ask me. Look at this problem number 8. All of you take your paper, pen, try to work it out right now. Ladies and gentlemen, can we get the nerve of it, sir? Sir, they gave me the volume of the solution as 100 centimeter cube. So I can use this formula. What is the formula I should use, sir? Molarity is equal to weight of solute by molecular weight into 1000 by volume in cc. Then I will be getting molarity. I don't waste my time in simplifying at this instance. I also find out that K is equal to what, sir? K is equal to what, sir? You remember Kr is equal to R. Rahim Khan is equal to cell constant. If Rahim Khan is equal to cell constant, K is equal to cell constant by R. So I got the K value. I know the molarity. Therefore, molar conductance is equal to K into 1000 by molarity of solution. Finally, I simplify and I approximate to get the answer 120. If I do it very accurately, my time will be wasted. So I will do it approximately. Can you see it clearly, sir? Hello?
Yes, sir. Yes, sir.
Can we really simplify it in 1 minute time? 1 by 520 into 153.7 into 10 to the power minus 2 into 1000 into 249.5 into 100 by 0.624 into 1000. This big calculation, can we do it in 1 minute time?
Yes, sir.
Probably you can do. If you see 10 to the power minus 200 is equal to 1, you will immediately ignore them. Then 1000 by 1000 will be 1. So on the right side, 10 by 2 disappeared, 1000 disappeared, 100 disappeared, 1000 disappeared. Simply you got 249.5 by 0.624. You have here 153 by 520. Can you see it clearly? Hello? Hello?
Yes.
So very quickly you can think that 520 into 0.624 is there in the denominator. If you multiply 520 into 0.624, you should see it as 31. Can you see it as 31 approximately? Hello? Hello? Sir, slowly we are doing, sir. We are not in a hurry, sir. I want to train you as to how to simplify it, please, if you permit me. Will you permit me?
Yes.
This 10 to the power minus 2 into 100 is equal to 1, sir. Any problem? Hello?
No problem, sir.
This 1000 is cancelling this 1000, sir. Any problem?
No problem.
Sir, this 520 into 0.624 in my mind, I see it as 1000 into 0.624 by 2 because 1000 by 2 is 500. So approximately I can think that this is equal to 32. Please take your time.
31.
520 into 0.64, I am seeing it as 1000 into 0.624 by 2 roughly, which is approximately equal to 32. Agreed? Hello?
Yes, sir. Yes, sir.
This 32, 153 by 32 is roughly equal to 5, sir.
Yes, sir.
Hello? Are we
Yes,
seeing
sir.
it together? Hello?
30.
So if you simplify like this, you will be getting an idea as to what could be the final answer. You require a lot of practice. Practice makes even a woman perfect. Okay? So use this and try to solve as many problems as possible. Let us look at the next problem. 0.020 molar KCl solution with a specific conductivity is given 0.2768 ohm inverse per meter, shows a resistance of 82.4 ohms in a conductivity cell, whereas 0.0025 molar K2SO4 solution in the same conductivity cell shows a resistance of 326.0 ohms. What is the molar conductivity of K2SO4? So for the first cell, first solution they gave K. For the second solution, they did not give K. Have you observed, sir?
Yes.
They gave me resistance
Yes, sir.
and they want me to calculate the molar conductance. Molar conductance is equal to K into 1000 by concentration. They gave me the concentration 0.0025, but they did not give me K. In order to find K, the resistance R is equal to what, sir? R into K is equal to cell constant. Hello?
Yes,
Yes, sir.
Yes, sir.
R into K is equal to cell constant means K is equal to cell constant by R. They did not give me cell constant, but in the first instance, I can calculate cell constants. How to calculate cell constant using first case? For KCl solution, cell constant is this much, RK, R into K. The same cell constant holds good for second experiment. So specific conductance in second case is equal to, sir, what is the formula for specific conductance, sir? Cell constant by R. Cell constant by R. What is the R value they gave me, sir? Hello? 326 ohms.
326.
Using this data, I use the K value. The K by, once I know the cell constant from this data, the cell constant by R is equal to K of second cell. Once I know K, I can find the molar conductance as K into 1000 by concentration. Are you seeing it very clearly? First data is used for finding cell constant for the resistance used to find molar conductance. If you practice, you will be able to do it. Okay, sir? So we
Yes.
understood what it is. Whenever I am adding water, I already said the number of ions in 1 centimeter cube volume will drop. Therefore, specific conductance decreases. However, overall conductance of the solution, as the number of ions can freely move as I am adding water, molar conductance increases. Up to what point it increases? You keep on adding water, the mobility of ions keeps on increasing till it reaches a maximum value. Then the solution shows maximum conductance called molar conductance at infinite dilution. Further, if I add, the conductance will not increase. So the peak value of conductance on adding that much amount of water is observed, which is called molar conductance at infinite dilution. As I am diluting, the conductance overall is increasing. The relation between the conductance at concentration C and molar conductance at infinite dilution is given by Debye-Huckel-Onsager equation. Debye-Huckel-Onsager. Onsager is not an Indian, he is an Australian. According to this equation, molar conductance at concentration C is equal to molar conductance at infinite dilution minus B under root C. It is looking like Y is equal to minus mx plus C. How a graph of minus Y is equal to minus mx plus C looks, sir? Hello? Can you see it? In this graph, what is Y, what is
Yes, sir.
C, what is mx? Can you see it, sir?
Yes.
Sir, here square root of C is taken on the x-axis. Molar conductance is taken on y-axis. The point of intercept is called molar conductance at infinite dilution. The slope of the curve is equal to B. Can you see it clearly? Y is equal to minus mx plus C, negative slope. Are we clear about it? Hello? It means as I am increasing concentration, conductance is dropping. In other words, if I am adding water, as I am diluting, the conductance is increasing. At this point, conductance tends to be 0. For example, you take 10 grams of sugar, you add 100 ml water, 200 ml water, 300 ml water, 10 million ml water. When you add 10 million ml water, concentration tends to 0. At that point, it will show maximum conductance. This linear variation, if you note what is the conductance at this concentration, conductance at this concentration, conductance at this concentration. If you increase the line length, it cuts here. The extrapolation of the graph between square root of C and conductance will give me molar conductance at infinite dilution for weak electrolytes. For strong electrolytes, the Debye-Huckel-Onsager law is acceptable by strong electrolytes. Strong electrolytes means strong acids, strong bases, salts of them. K2SO4, Na2SO4, KOH, NaOH, H2SO4, HCl, HNO3. All these strong electrolytes obey Debye-Huckel-Onsager law. For them, the variation in molar conductance with concentration, square root, is a straight line. The extension of this graph will give me molar conductance at concentration C. The topic under discussion is electrochemistry. We are talking about conductance. We agreed upon that the opposing force to the current flow is called resistance. And we recorded that the current passing through a conductor I is always directly proportional to voltage difference, inversely proportional to resistance. V is equal to IR is Ohm's law. We understood what is conductivity, what is conductance, what is molar conductance, what is equivalent conductance, what are their units. For any given cell, the cell constant L by A remains constant. Always we remember that Rahim Khan is cell constant, RK is cell constant. K is equal to cell constant by R. 1 by R is called conductance, represented by G. Therefore, G star is equal to what, sir? What is G star?
K.
G star is equal to G star by R. G star by R is nothing but K. K means what? I noticed that as I am adding water, molar conductance is increasing. The relation between molar conductance at concentration C and molar conductance at infinite dilution is given by Debye-Hückel and Sagar law. The graph of this looks like Y is equal to minus mx plus C, or molar conductance at concentration C is equal to molar conductance at infinite dilution minus B root C. A graph of molar conductance versus concentration of square root C is a straight line with negative slope. It is a story so far. There can be problems based on this. This is the sheet I have shared with you. I want you to try these problems. Can you try these problems, sir? Hello?
Yes.
Now I want to examine the NCERT book before I go to this. Why this dirty paper is not getting open? Sir, we have a lot of time. Don't worry. Slowly we do. I am not in a hurry. We should get the concept. Line by line we scan. Line by line. No compromise. If required, we take extra time. 3.15. Explain how rusting of iron is envisaged as setting up of an electrochemical cell. In an iron surface, the broken part, which is filled with rainwater or acidified water, acts as anode. The surface part acts as cathode. The acidified water acts as electrolyte. The iron atoms in the broken part lose electrons to become iron plus 2. In presence of that acidified solution, the oxygen which is there in the environment, yet a cathode takes those electrons and become hydroxide ions. So as a result, I get FeOH taken twice. The FeOH taken twice slowly reacts with atmospheric oxygen to become Fe2O3XH2. This phenomena is called rusting, and in the rusting there will be millions of tiny electrochemical cells produced between the broken surface of iron and the outer surface of iron through electrolytes like acidified water. Look at the diagram. This is exterior and a broken part. The broken part is in contact with water droplet connecting the surface and broken part. The broken part, iron is becoming iron plus 2, losing 2 electrons. Those electrons are captured by oxygen of air in presence of H plus ions to become water. Iron becomes ferrous, Fe plus 2, and then ferric. Mind you that millions of such broken points make millions of cells. At the end, all the FeOH twice will become Fe2O3. Fe2O3XH2O is called rust. Simple. All the metal which have negative potentials can undergo rusting. In rusting, the metal will become its original ore. The metal becomes original more because of its interaction with atmospheric gases. That is encouraged by water droplets. There is an interesting question, sir. Look at this question. Let us investigate the answer. Somebody has taken a iron nail, and the iron nail they kept like this in a beaker, and they poured acidified water. Now, question is, which part is rusted rapidly, the outer part or inner part? Which gets rusted rapidly? Can you answer, sir? Hello? Hello, are you there?
Yes.
Sir, an iron nail is kept in a beaker containing water. A part is outside the water, a part is inside the water. Part A, part B. Which part gets rusted, sir, quickly? Auntie or boy?
In water, sir.
The auntie part which is inundated in water gets rusted because the oxygen dissolved will come here and take away electrons. As oxygen is removed, more and more oxygen will dissolve, according to Le-Chatelet principle. Therefore, the part which is immersed in water undergo rusting rapidly. Are we clean on this idea, sir?
Yes, sir.
Now I was wondering, the NCERT book we are exploring, the last point we have seen is rusting. And who will undergo rusting? All metals which are having negative potentials. Gold will not be rusted because gold is having highly positive electrode potential. It never prefers to lose electrons. What is the formula of iron rust? Fe2O3 What is the reaction happening at cathode when iron is rusting? At cathode, there is reduction. Oxygen takes electrons to become water. At anode, iron loses electrons to oxygen to become ferrous ions. The ferrous ions further take oxygen from air and become ferric oxide. What is the cell potential in this case? Higher potential minus lower potential. 1.67 minus 1.23. Summary. Some active metals have negative electrode potentials. When they are kept in air, they slowly lose electrons to oxygen of air. The reaction is encouraged by water, acidified water. If I immerse a nail in a beaker half filled with water, the part that is immersed in water undergo rusting rapidly than that which is not exposed to water. This is rusting we have seen yesterday. This is called fuel cell, into which oxygen and hydrogen or any two fuels like methane, ethane, cooking gas is pumped from one side. Something that supports combustion like oxygen is pumped from the other side. Instead of oxygen, you can use fluorine, chlorine. The fuel cells are supposed to be more efficient. They are used in space missions, but we don't have technology to make fuel cells in large scale today. Fuel cell is silent, it won't make any noise. Fuel cell is 100% efficient theoretically, maximum 70% efficient things are available. Easy to handle, but the technology we have to develop yet. This is a nickel cadmium cell. Cadmium is the loser, nickel hydroxide is the gainer. At the end, you get CDO nickel hydroxide, where nickel is dipositive. Since it does not have any ions and water solution, concentration changes will not affect it. It will give a smooth voltage. Ordinary course secondary cell. A cell that is used in watches and electronic devices. the original dry cell made with the zinc dabba, carbon rod, manganese oxide. Read the lesson, it will be easier to understand. Zinc is the loser of electron, MnO2 is the gainer. Ladies and gentlemen, I request you to look at next part. Before you go, so far we have discussed what is conductance, what is resistance, what is cell constant L by A. Rk is equal to cell constant. K is equal to cell constant by R. Once I know K, molar conductance is equal to K into 1000 by molarity. K has units of Siemens per meter or Siemens per centimeter. Is it true, sir? Hello? The molar conductance on adding water will increase. The maximum value I see is called molar conductance at infinite dilution. Now the conductance at concentration C is always less than conductance at infinite dilution. Conductance at concentration C is equal to conductance at infinite dilution minus B root C. This is Y is equal to minus mx plus C. A straight line with a negative slope, valid for strong electrolytes. For weak electrolytes, it is not valid. But I want to know always molar conductance at infinite dilution, because the ratio between molar conductance at concentration C, molar conductance at infinite dilution is corresponding to alpha degree of dissociation. So knowing alpha is very, very important. Why it is important? Unless I know alpha, I can't calculate the H plus ion of a weak acid. Unless I know alpha, I cannot calculate equilibrium constant in a cell. Sir, what is the alpha degree of dissociation? Molar conductance at concentration C by molar conductance at infinite dilution. Look at this, sir. When I am passing current through a solution that contains Na plus and H plus, both Na plus H plus wants to take electrons, but the ability to take electron is least for first group, second group metals. The H plus has higher ability. Therefore, the first, second group metals keep quiet as Na plus or K plus or Rp plus. The H plus will take electron to become H2. So, in electrolysis, first group, second group metals and aluminum will not undergo any reduction. It is the water that undergo reduction to give hydrogen. What is the reaction that happens at cathode when sodium ions are subjected to electrolysis? At cathode, water gains electron to become hydrogen and OH minus. Because Na plus is not able to take electron, the Na plus will be happy with OH minus, it becomes NaOH. Can you work out this, sir? At the anode, what reactions are happening? At the anode, chloride minus wants to lose electron, water also wants to lose electron. In this competition, to undergo oxidation potential for chloride ion is more, so we think that chloride ion should lose electron first. But unfortunately, the water can lose electrons to give oxygen. depending on the concentration of chloride ions. If there is good concentration of chloride ions, you will get chlorine gas. If the concentration of chloride ions is less really, then you may get oxygen gas. Remember, reduction reaction is favored by high SRP value. Oxidation is favored by low SRP value. Notice that the chloride ion has higher SRP, water has lower SRP. So, who will undergo oxidation first, sir? Water should undergo oxidation first. But in practice, the generation of oxygen demands a little higher voltage. Therefore, you are getting both chlorine and oxygen. Normally, we expect oxygen to come out, but only oxygen is not coming, chlorine is also coming because of oxygen over voltage problem. Sir, if I am looking at water whose molecular weight is 18, H2O offers 2H plus 1O minus 2. It means if I pass 2 Faradays of charge through 1 mole of water, it will break down to give oxygen and hydrogen. When you take concentrated sulfuric acid and pass current, what happens is presented here. If the concentration of sulfate ions is higher, the sulfate ions will lose electron. If the concentration of sulfate ions is lower, the water will lose electrons to give oxygen. It depends on how concentrated the sulfuric acid is. So this is a note on electrolysis. I want you to read the book line by line, have time. Today you have to do following things, sir. First thing is, read the NCERT book last 7 pages. What are the last 7 pages? Different cells. What are the last 7 pages, sir? You are going to read thoroughly about the summary. 3.13, 3.14, 3.15, try to do yourself. Try to read once what is corrosion, what is a fuel cell, especially reaction cathode reaction diagram. Nickel cadmium cell, that nickel NiOH taken thrice plus cadmium would react. Secondary cellular car battery, lead peroxide, sulfuric acid, charging, discharging. What is this, sir?
Zinc mercury cell.
Mercury cell, which we use in. This is the reaction. Zinc amalgam plus HU. Trace. So up to this point you read, sir. 3.5.1. If possible, you start here. For 3.5, go to end of the book. All your doubts you write down in a piece of paper, we will discuss. This takes about 1.5 hour time to 2 hours. 3.5 to end of the book. Today, theoretically, I covered these ideas about conductance and all. Tomorrow, once again, we revise them. But today, you do up to this 3.5 to end. Tomorrow, we will come from 3.5 backwards. All these graphs we see once again. All this I explained just once. The measurement of the conductivity of the ionic solutions we see tomorrow. Okay. You have to read the book, and I have sent you one exemplar problem. Try to solve them. Unless you ask me specific doubts, I can't be able to help you. Okay, sir? Thank you very much. Kazim is calling. Hello. I just switch off the phone. Hello, sir. Hello.
Yes, sir.
Now, slowly we will be visualizing this topic scope, sir. In this topic called electrochemistry, we started with a discussion of what is electrode potential. When a metal is immersed in its salt solution, when that is connected with a hydrogen electrode, it can show a behavior where it can lose electrons or where it can gain electrons. Using that tendency, we can construct the cells, and in the cell, we can generate electric current. What are the rules of the game to construct such cells? How to calculate the cell potential? Nernst equation tells us how to increase the cell potential. In that discussion, we will come across what is standard hydrogen electrode, what is a calomel electrode. That is the first part. Second part is what is conductance, how to measure it, and what is specific conductance, what are the simple problems related to it. Then we have seen what is molar conductance, conductance at infinite dilution. Ratio between conductance at concentration C and infinite dilution is called alpha. Alpha is useful to calculate many things like H plus ion concentration of weak acid, C alpha. Dissociation constant of a weak acid, C alpha squared by 1 minus alpha, all those things. Next part of this chapter is cells. And the last part is corrosion. These are the aspects. It takes time to read the lesson. So you read it. Hydrogen economy means, how to generate hydrogen. Nowadays, the petrol is causing a lot of pollution, carbon, coal, all they are causing pollution. Now, without pollution, you want to make a cell. The cell works by passing hydrogen from one end, oxygen from one end, that is called fuel cell. To operate a fuel cell, you require constant supply of hydrogen. So the economic welfare of future countries depend on how you generate hydrogen, how you use hydrogen. All the money which India is spending to buy petrol from all Saudi Arabia, Iran, Iraq, it is in the billions of dollars. All that can be saved if we can make fuel cells that run the cars, that can run the buses. So the knowledge related to generation of hydrogen and its usage in fuel cells is called hydrogen economy. That will make a big impact in our lives. That is a note on hydrogen economy that has been discussed in the textbook in the last page. Just we see it quickly. What is hydrogen economy? Last. The main source of energy that is driving our economy is fossil fuel like petrol, diesel, gas. As more people on the planet are interested to have cars, sports cars, all varieties of transports. They are burning more and more petrol. Their energy demand is increasing. The wealth of a country is decided by how much energy is utilized by Indians or by the citizens. More is the fuel you are using, you are supposed to be richer. Okay. Now, all these gases produced by combustion of fuel are causing rise in temperature. They are called greenhouse gases. They are raising the surface temperature of the earth and causing flash floods and so many problems. In order to avoid this big danger, there is a story about a gentleman going from Mars. He says that the Mars was having a big population once upon a time. All people died because of nuclear wars and excess use of fuel. It seems there is a note about that boy. Like that, the earth may perish if the people start quarreling in the names of so many things. You know why people are quarreling? Hello? Hello?
Yes, sir.
What is the point why people are quarreling? People want to take wealth from one country to the other country, or people want to establish that this particular religion is good over the other. On the ground of religion, on the ground of wealth, on the ground of caste, on the ground of many things, people are quarreling. And if they throw nuclear bombs on one another, all will die. Okay, that's for sure.
Yes.
Therefore, people should avoid using what that causes pollution. One of the aspects that causes pollution is petrol. Instead of petrol and diesel, it is better to use hydrogen. When hydrogen is burned, you get water vapors. That is not causing any pollution. Hydrogen production must come from splitting of water using solar energy, because solar energy is free of cost, cheap. So hydrogen can be used as a renewable and a non-polluting source of energy. The study related to this, how to generate hydrogen, how to use it for welfare, is called hydrogen economy. And the generation of hydrogen is definitely based on electrochemical principles. So hydrogen economy talks about usage of electrochemical cells that generate hydrogen. So that is what you asked. So try to read the lesson, and we will be doing some problems from these exemplar problems tomorrow. These are exemplar problems. I will show you once before I close this. Please